Hi, so today's video is about the definitions of potential energy and the definition of gravitational potential energy, as well as it contains the derivation of the gravitational potential energy, and also there are some notes or the important points regarding the gravitational potential energy. So please do watch the full video, and if you like my video, please do like, share and comment, and also please don't forget to subscribe to my channel because your subscription means a lot to me, and also press the bell icon to get the notification first of whatever I upload. So I am Dinesh, you are watching the Dinesh Nayal classes. So let's start with our class today. Potential energy. The potential energy of a body is defined as the energy possessed by the body by the virtue of its position or configuration in some field. Now see, thus the potential energy is the energy that can be associated with the configuration of a system of objects that exerts force on one another. Obviously, if the configuration of system changes, then its potential energy will change. For an example, when we wind the spring of a watch, the potential energy is stored in the spring on account of configuration of the turns of the spring. As the spring unwinds, it works to move the hands of the watch. Thus, the wound spring has the potential to do work. Similarly, when a spring is compressed or stretched, work done in compressing or stretching the spring is stored in the form of its potential energy. So there are mainly two types of potential energy, that is the gravitational potential energy and the elastic potential energy. So in this class we will discuss only the gravitational potential energy. So gravitational potential energy. Gravitational potential energy of a body is the energy possessed by the body by the virtue of its position above the surface of the earth. In fact, the amount of work done in carrying the body from surface to earth to its present position against the gravitational force of earth is stored in the body in the form of gravitational potential energy. Now, when the body is allowed to fall from that position, it can do the amount of work equal to its gravitational potential energy. To calculate gravitational potential energy, suppose, now let's we take m is the mass of the body. Now m we take as the mass of the body. Okay. G is what? Small g is the acceleration due to gravity. Now this is the acceleration due to gravity, and h, this h, that is equals to the height. This is equals to height through which the body is raised. The body is the height through which the body is raised. Now, if we assume that the height h is not too large and the value of g is practically constant, then the force applied to overcome the gravitational force of attraction is given as F is equals to m into g, which is basically the weight of the body only. You see this diagram. Now, the force is applied and the height through which that body is raised is h. So force is what? Force is mg. Now, as the distance moved in the direction of the force applied, therefore work done. Now what is the work done? Work done equals force into distance. Now we know that force is what? Force we have calculated to be mg. So just write F. Distance is basically the h, the vertical height above. So this is the h, F into h. So this work done, substituting the value of F as mg, is mgh. Work done is mgh. So the gravitational potential energy of the body. Now, so this is what? Gravitational potential energy of body. So this is equals to work, which is equals mgh. Now as you know, at the surface of the earth, what is h? H is what? H is 0 at surface of Earth. Now at surface of Earth, H is 0. So what will be the gravitational potential energy? The gravitational potential energy, that will also be 0. Now as we know that W is mgh, so gravitational potential energy varies directly as the mass of the body and also directly as the height of the body above the surface of the Earth. Now the following points is to be considered, means the following point which is to be noted. Gravitational potential energy associated with a particle Earth system depends only on the vertical position of the particle relative to the reference position, not on the horizontal position. The next point, potential energy is defined only for the conservative forces. So it is defined only for the conservative forces. It does not exist in a non-conservative forces. So now, next point. Potential energy depends upon the frame of reference. That may be positive or negative. By convention, gravitational potential energy of a body is said to be positive when work is done by the body in returning to its reference point. So the work done is what? Positive. Is said to be positive when the work is done in returning to its reference point. Now, similarly, gravitational potential energy of the body is said to be negative when the work is done on the body to bring it back to the reference point. And also the last point, work done in assembling a body from infinitesimally small fragments distributed initially at infinite separation is also stored in the body itself in the form of its self-potential energy.